Hello and most welcome to 2083 of the series. We will today continue with Frank Wilczek's excellent book, The Lightness of Being, Mass Ether and the Unification of Forces. Unification of Forces.
Force.
Force. We are currently talking about Maxwell and how there was a development in what we could call the grid. I would use Wilczek's expression grid here, and that's a sort of universal for all the different aspects of Newtonian, Aristotelian, Maxwellian space. There is the first change, the original way that things know about each other were by touch, touch, touch. So knowledge between two things or entities was gained by them touching each other. In the Aristotelian pre-Socratian and post, of course, that even including Cartesius, that changed considerable within the Derridian take. Oh, sorry, Newtonian take. Because from then, that time onward, we ventured into effect or touch at a distance. Newton himself, as pointed out specifically by Wilczek to be didactic, did not like that. And I would say no one else at that time. That's 1689, the publication of Principia, that was liked by no one in the world. Pretty sure about that. So what has happened since, we've gotten used to that. That being the case, and we take it for being the foundation of the world. But we forget that gravity was a big addendum, additive, and it changed everything. What later happened is then entered also Maxwell and Faraday, and all of a sudden we got an even greater change to the grid. We got the electromagnetic force, or the electromagnetic fields. And they are light. So you see here, we are already pretty close to the Einsteinian worldview. This is space's touch, or to be even more correct, that space is touching. The capacity to touch, that is what space is. It's the touching ability. What does space do? It knows, it feels. A new way of feeling in Newton, and an even newer or one time more distant way of feeling is the electromagnetic, that is light. And as we know, light in the EMC square of Newton is in some way what space is. Space is light. So you see here how the grid fundamentally changes. This is, and it's so important to know that our current way of viewing things is Newtonian. It's not Maxwellian nor Einsteinian. And it is most definitely, it's not quantum mechanical at all. We are sort of stuck in the Newtonian touch of gravity. I think it could be fair to say that makes sort of space feeling a very distant way of having connection to space. Simply not present. It's space at a distance. I think this aptly could be, and I will get back to this. I've been reading how language changed by Newton, and that's the biggest change that happened to language. It's the Newtonian change. And I think I think you know pretty well that normalization is a rather new thing, that turning action into an entity or a thing, and then sort of grading that thing by adjectives. Adjectives are properties and Newtonian take. But you can see the likeness here. I think I sent that book even to you, Kalle, about how language changed. I came to think about it now. One aspect of that is we get this human, we see ourselves as a human walking around in the Newtonian space, somewhere from the outside. So this outsideness of Newtonian is well established within normal argot, how we talk. No one is outside of this Newtonian take. No one. We see ourselves as some sort of figures, and we are viewed in our aspect of the panopticon, what Thomas Nagel calls the view from nowhere. Whereas I would say that the pre-Newtonian philosopher or anyone had a pretty good feeling that it had to be an observer, a toucher, either a second object or a human being. But this is lost in modern language. We no longer have access to those deeper senses of space. Well, I will continue where we left off at page 78.
78, the test of time.
78. And we are on the second paragraph. And we're just speaking about Maxwell. And how the Maxwellian take is equaling light. The presence of light is space. And the last sentence where I was actually pretty deliberately massive, a conclusion that has stood the test of time, and that is that space is light. The magnetic, electromagnetic fields. For Maxwell, these fields that fill all space and take on a life of their own were a tangible symbol of God's glory. The vast interplanetary and interstellar regions will no longer be regarded as waste places in the universe, which the Creator has not seen fit to fill with the symbols of the manifold order of his kingdom, of his kingdom, of his kingdom.
Kingdom.
We shall find them to be already full of this wonderful medium, so full that no human power can remove it from the smallest portion of space or produce the slightest flaw in its infinite continuity. Its infinite continuity. Einstein's relationship with the ether was complex and changed over time.
Ouch, ouch.
Changed over time. It also, I think, poorly understood even by his biographers and historians of science. In his first 1905 paper on special relativity, on the electrodynamics of moving bodies, he wrote, "The introduction of a luminiferous ether will prove to be superfluous inasmuch as the view here to be developed will not require an absolutely stationary space." Absolutely stationary space provided with special properties. Nor assign a velocity vector to a point of empty space in which electromagnetic processes takes place. takes place. Takes place. So not an absolutely stationary space. That forceful declaration from Einstein puzzled me for a long time for the following reason. In 1905, the problem facing physics was not that there was no theory of relativity. The problem was that there were two mutually inconsistent theories of relativity. On one hand was the relativity theory of mechanics, obeyed by Newton's equations. Obeyed by Newton's equations. On the other was the relativity theory of electromagnetism, obeyed by Maxwell's equations. Maxwell's equations. Both of these relativity theories show that their respective equations display boost symmetry. That is, the equations take the same form when you add a common overall velocity to everything. In more physical terms, the laws of physics, the physical laws, look the same to any two observers moving at the constant velocity relative to one another. One another. One another.
Two observers moving at a distant velocity relative to one another.
One another.
The laws of physics look the same.
To get from one observer's account of the world to the other, however, you have to relabel positions and times.
Relabel.
Relabel. Do them over again. An observer on a plane from New York to Chicago, for instance, would in a couple of hours label Chicago as distance 0. whereas Chicago would still be distance 500 miles west, roughly, for the observer on the ground. The observer on the ground. The problem was that the relabeling required for mechanical relativity was different from that required for electromagnetic relativity. Electromagnetic relativity. Electromagnetic relativity. According to mechanical relativity, you must relabel spatial positions, but not times. Whereas according to electromagnetic relativity, you had to relabel both. In a rather more complicated way that mixes space and time together. Space and time together. Einstein's great innovation was to assert the primacy of electromagnetic relativity and work out the consequences for the rest of physics. The rest of physics. So it was the venerable theory of Newtonian mechanics, not the upstart theory of electromagnetism that required modification. 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 The theory based on particles moving through empty space gave way, not the theory based on continuous space-filling fields. Maxwell's field equations were not modified by the special theory of relativity. On the contrary, they supplied its foundation.
Foundation, foundation, ta-da-ba-ba-bum.
One still had the space-filling, potentially self-regenerating electric and magnetic fields that sent Maxwell into raptures. Into raptures. Indeed, the ideas of special relativity almost require space-filling fields. And in that sense, explain why they exist, as we'll discuss momentarily. Momentarily. Why then did Einstein express himself so strongly to the contrary? True, he had undermined all the ideas about a mechanical ether made of the particles following Newton's laws. In fact, he had undermined those laws altogether. Altogether.
Ouch, ouch, ouch. Var nyt on.
But far from eliminating space-filling fields, his new theory elevated their status. Elevation. He might have said with more justice, I always thought that the idea of an ether that looks different to moving observers is wrong. But a reformed ether that looks the same to observers moving at a constant velocity relative to one another is the natural setting for special relativity. Special relativity.
Look the same to observers, moving at a constant velocity. Plunk, 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 plunk.
Look, look. Or Eddie Murphy laughter. At the time he was hatching special relativity in 1905, Einstein was also brooding over the problem of what later became known as light quanta. Light quanta. Light quanta. A few years earlier, in 1899, Max Planck had put forward the first idea of what eventually became quantum mechanics. Quantum mechanics. Planck suggested that atoms could exchange energy with electromagnetic fields, that is, emit and absorb electromagnetic radiation, such as light, only in discrete units or quanta. Using that idea, he was able to explain some experimental facts about black body radiation. Black body radiation. Black body radiation.
Radiation. Pyum, 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 pyum.
Black body radiation. And I will read the parenthesis here because it seems very important. Very roughly speaking, the problem is how the color of a hot body, such as a red hot poker, or a glowing star, depends on its temperature. Less rough, but still far from smoothly polished. A hot body emits a whole range of colors with different intensities. With different intensities. The challenge was to describe the whole spectrum of intensities and how it changed with temperature. There we have the black body so nicely and cutely added up. And I think that's a good time to pause, because the black body problem has never been that succinctly and exactly put. So do remember this. This needs to be remembered, engraved in stone or written with gilded letters. So
Black body.
Indeed. So temperature would be the last word, and Planck's be the first word.
And let me see. And page 80. Temperature. Temperature.
Page 80. The black body problem was one of those things that sent the Newtonian physics out of the room, never to be regained again. And of course, it is mentioned here because it changed everything. All of a sudden, we got a completely new space, a new way of touching. Page 79, please, Kalle. You may.
78 or which page?
79, please.
79. Excuse me. 79, 79.
We go to the top there. It's very succinctly put here. We will no longer require, the second line here, will not require an absolutely stationary space. Absolutely stationary space. There's no longer any need for the foundation of an absolutely stationary space. And as I mentioned so many times before, and you must be tired of it by now, that the very idea of a orthogonal perpendicular XYZ dimensional system of Newton is now broadened and widened, not only discarded, I would say, but it's much wider here. It's a new way of touching things. So what does this mean? Well, you can say it like this. In Newton, the observer disappears completely because there is no longer any touching. No longer feeling, viewing, hearing, tasting, sensing, none of those things. They all disappeared. They are no longer present in the Newtonian gravitational sensing. This is, I spoke to Henry the other day, Henrik, and he said, well, that is the entrance of a transcendental Tegmarkian world. Yeah, it is the very seed of that, the Evereshian idea of the world being beyond us, or that we are small figures walking around in this absolutely stationary space. And this is getting challenged heavily, actually discarded already with Maxwell and Faraday. Go to the third paragraph here. And looking at, if you go down a bit there, Kalle, please, yeah. Both of these, oh, it's a bit too much. The third paragraph, please. Yeah, thanks. 1, 2, 3. Both of these relativity theories show that their respective equations display boost symmetry. That is, the equations take the same form when you add a common overall velocity to everything. A velocity to everything. So the overall velocity will later be c, the velocity of light. So now you will understand better why space is light. Well, because it has the same velocity. The velocity is very important here. And as you can figure out velocity is, of course, both time and space. Go down on the page there. Oh my God, it's like 20 lines down, beginning with according. Just switched by there. Yeah, according, yeah. You see it? Yeah. According to mechanical relativity, you must relabel spatial positions, but not times. We well know that. But listen now. Now comes the great thing. Whereas according to electromagnetic relativity, you had to relabel both. Entrat, the luminiferous space, or space as being enlightened, or being light itself. That is indeed grand. Now we have a much more flexible, a much more encompassing and allowing space. No longer, and this is so great, no longer do we have the idea that man, the ego, the I, is only a little dot in the orthogonal perpendicular Newtonian absolutely stationary space. No. Now we have a grander space. Of course, this space can make the Newtonian space, but you can't go the other way. You can't derive this grander space from the Newtonian. But in a very clear way, this grander space is the birth mother of the Newtonian space. There. I really put it in layman's terms. But you could also say another way of looking at this, that the panopticon replaces the necessary God that was before Newton. He was the toucher, he was the sensor. He was asked to Berkeley, how can a thing exist when no one's there? Well, God is there. So we need to go back and regain our own senses. And there is no happenstance. There's no there's no chance that it's no coincidence. That's the better English term. There's no coincidence that modern man lack proprioception, has no fantastic connection to his own senses. The reason for that is we have this absolutely stationary space, and that gives passivity. It doesn't matter how much you jump up and down within it, you will still be ontologically. Does that make sense? Ontologically passive? I hope that makes sense. Ontologically passive. Because the space we have naturally, without effort, excludes presence of a human being or an observer, to be more correct. And it excludes effectively God. And it also excludes free will. So I think the didactics of Frank Wilczek is just amazing. Now we laymen, yeah, although I'm an engineer and all that, yes, true, but it is fairly complicated. And it's definitely one of those understandings that passes without notice through most of scientists as well, not only we lay people. But it's deeply ingrained in our fundamental thinking, which is the stationary Newtonian space. And to end with the last This is more to be remembered. It doesn't go to page 80, please, Kalle Lundahl. Go to the third paragraph here. And it was a mentioning before that the space-filling, potentially self-regenerating electric and magnetic fields sent Maxwell into raptures. And this is absolutely correct. It is beyond belief fantastic. It's miraculous, I would say. And if you go to the third paragraph, the third line, a few years earlier in 1899, a year to be remembered, third paragraph, if you could go down a bit, Kalle. 1899. Could we go down a bit? To the third paragraph, please. A few years earlier, in 1899, Max Planck had put forward the first idea of what eventually became quantum mechanics. So you see how quantum mechanics comes from light quanta, the luminiferous space. This is a segue into understanding quantum mechanics. It's a different space. The last parenthesis is just to be remembered. Doesn't take any part in my summary, but do study it when you get the chance. If you feel it's very rewarding, it will help you to segue into understanding what pushed science into this better space. The observer-dependent space, or the luminiferous space, or why not the God space? I almost come into raptures myself. Please, Kalle Lundahl, any comments?
Let me go to page 79, 79, so it's about this. An observer on a plane from New York to Chicago would in a couple of hours leave Chicago as distance 0, whereas Chicago would still be distance 100 miles away, roughly from the outside of the ground. So this is, we could compare this with the famous image duck and rabbits. So the duck would be traveling on a plane. No, the duck would actually fly from New York to Chicago. So for this duck, the distance would be 0.
Oh, okay, let me stop you there for a second. I can't hear you clearly. You need to keep your microphone a bit closer to the mouth, I think.
So this observer on a plane from New York to Chicago would in a couple of hours leave Chicago as distance 0. So this would correspond to the duck in the image of the duck rabbit.
Yeah.
Whereas Chicago would still be distance 100 million miles west from the top of the ground, that is rabbit, let's say, rough. But they're both correct. They're complementary, so to say.
Yeah, it's very good actually, because you can compare it to the bigger space where you need to relabel both time and space. Great, yeah, you got it, Kalle. Very good.
Thank you. And then, what is the great discovery? In electromagnetic, according to electromagnetic relativity, you have to repel both. So this means that space and time are secondary. Space and time are secondary.
Yeah.
What is primary? Primary is the relations. That is according to Karl. And we can agree, and I think also Wilczek agrees with Karl in this, that what comes first, that is relations. Relations, for instance, between observers.
Indeed.
And space and time come only secondary. And if you think about the rabbit and duck image, there is really no time there. What is important is the relation between two animals. And let me take another mention to other animals.
Could you speak closer to the microphone? I can't really hear you.
Let me mention other animals. The chicken egg problem. The chicken egg problem. Do you hear me?
No, I can't make you out.
The chicken egg problem. Let me read. At the time, he was hatching, yummy.
Yeah.
At the time, he was hatching special relativity in 1905, blah, blah, blah. So this made me think about the famous chicken egg problem. What came first, the chicken or the egg? And in this image by Wilczek, Einstein would be the chicken because he's hatching. But let me switch metaphors. Since Einstein begins with an I and egg begins with an I, let me say that
it's an I there. I liked your I there, because I of the ego, which is either placed within the vacuous stationary space, or active is in this new moving space. Yeah, great.
And I think also that Einstein had a great ego, perhaps, so it works very well with the E.
Yeah.
Or rather, he wanted a stable ego. He wanted stability, so I think it works in that way. But anyhow, so the question is, what came first, chicken or the egg? And this, we know now that time and space are secondary.
Secondary to relations, yeah, indeed. And this parallel.
This is a paper from Cosmos on Cosmos. So was it the chicken or the egg?
Very good. And so close to Easter as
my
well.
internet connection is unstable. Absolutely. Let me go down.
I like that.
So I can read. Using two of the most powerful and complex theories of modern physics, quantum mechanics, general relativity, a paper published in Nature Communications reveals that the answer is both or neither.
Neither, yeah.
The notion of time order is not predefined. Time does not exist out there in the level of our experiments.
Yeah. And this also goes back to you should look it out, the quantum Zeno effect, where we can see how the observer little by little creates time. This is too great. Thank you very much. Could we end with the chicken there? Because I think it was such a great ending there. Yeah.
Yes, that's good.
I will take it up next time, the quantum Zeno effect, because it's very relevant. Thank you for bringing that in here. And I do like the little chicken. Thanks for your comments, Lundahl. It was very illuminating, luminiferous, and it will send us all into raptures. Thank you, everyone, for joining. Yeah. Have a beautiful morning, day, or afternoon, wherever you are. Bye-bye for now.